Welcome to part 7 of the Bionic Hybrid X210 build instructions. Okay, so the first thing we must do before connecting our VTX and camera is decide on what voltages that our VTX and camera will actually be using. Now, we do this by looking at the PDB and selecting, here's the VTX part, and these are little solder tabs, and I've soldered these two tabs together to select 12 volts. So that means that 12 volts will be presented on this positive pin here, ground here, and this is where your VTX yellow wire will, it's normally yellow wire, will go to your VTX. So if I unsoldered that and soldered these two together, this pin here would be equal to VCC, which is your battery voltage, which on a 4 cell would be around about 16 volts approximately. Similar solution on this side. Whereas here I've decided to choose 5 volts, so I've soldered these two tabs together, and that will present 5 volts on this positive pin. Now, you probably noticed that the camera can take up to 22 volts, so why am I only using 5? Well, for me I suppose it's logical. I need a 5 volt supply here anyway. This has been regulated anyway. Battery voltage down to 5 for the NAS 32. So why push, say, 12 volts or VCC into my camera just so the camera has to regulate it down to 5 volts too? That's just going to waste extra energy. Wherever you regulate voltage, there's always a slight waste, and that usually generates heat. So we're just going to use 5 volts there. We don't need anything more. It's also more compatible as well with a lot of other cameras, and some cameras aren't compatible to 12. I once burnt out a GoPro by having it set to 12 and just plugging it in, not thinking, and well, the old magic smoke was released and a very expensive camera broken. So 5 volts, play it safe. Here's the VTX with the stubby antenna attached. So this is the red and black wire. We'll be sending 12 volts down here, and the yellow wire will be going on to the appropriate solder pad. This is the HS1177 camera from Fox here. Again, this will be run on 5 volts. We'll chop this cable at the desired length, and we'll see that in a moment. What we need to do is consider what frequency we want to fly on. This is set by these dip switches. So I put this little chart together, and this is what I use. So I would fly on band E4, and a mate of mine would fly on E8, and that gives us 300 megahertz between each video signal, which basically is definitely not going to interrupt with each other. Note that, just because you can't choose sort of, well, if I'm on band E, then somebody on band A will be definitely further away from me. It doesn't work like that. It's not even linear. So each band and each frequency number necessarily won't even follow any particular pattern. They're just frequencies. So this is looking at all the bands and trying to look at which ones are furthest apart and in which order to use them as pilots join in the fun. So it's only myself and Chris, so I use band E4, which is band 3, frequency 4 on my Sky Zone goggles. So that means I have my settings where it's down, down, up, up, down, down, and I use that on all my drones, so I know which frequency I'm on. My goggles are always set to it, and so is my equipment here in the workshop. Looking at the back of the camera, we've got 5 to 22 volts in here. We'll be feeding it with 5. Ground the black wire here. The video signal, the output video signal comes through the yellow wire here, and this pin should here be blank. This is for the OSD. And if you bought one of these new, then you'd have OSD setting functions inside. OSD doesn't mean all the nice stuff you get with FPV OSD. It's actually to set up the camera itself. And you don't need to do any of that. If you bought one of these brand new, it should be set out of the box, and it should be ideal. So let's see it being fitted. So assuming you've set those solder tabs and you've chose your voltages correctly, let's actually solder the actual VTX onto the PDB. I'm just going to make these a little bit smaller because you don't want anything overlapping the solder tab. It just needs to be a little piece of wire at the end, tinned and ready to go onto that solder pad. the solder pads are extremely small, and if you've got too long wires, they'll actually sit proud off the end of the circuit board, or worse, go off the other side into the circuit board and maybe touch something else. So let's solder that on down. Might as well fast forward over this, nothing really to see. So that done, let's look at where the camera's going to be. So we need to chop this lead off, but obviously we don't want to make the leads too small. Just note on the VTX, I did leave the leads quite long, and the reason for that is because the VTX will be mounted to the top part of the frame, and sometimes you want to move the frame for maintenance, take it to bits, and you need to be able to push it to one side, so it's worth having a little bit extra. But here, for the camera, what you'll notice is that I'm going to cut the wire, so it's just about right, enough to go under the PDB and come back out and be actually soldered. So again, I'm just gonna solder this in, so not a lot to see, so I might as well fast forward. So now we need to start looking at fitting the actual camera itself on the front, so hopefully you spent some time filing the frame parts so all the parts fit. So we need to put the sides in there, remembering to put the rib side of the camera support, the camera mounting, to the outside of the model. And what you should do here is you should be able to slide the camera in, and you shouldn't clip nice and in there and feel quite firm even without the screws in. It's not going anywhere, it's sitting inside the little holes there that's made for it. And the camera itself comes with these little tiny self-tapping type screws. You need to put in really quite tightly into the side. Once they're in correctly and tightened up, the camera should be pretty well fixed into position. And you find that with flying, it generally doesn't move. I mean, okay, in a hard crash it might, but certainly in flying it won't move. As you can see, once it's in, it takes some force to actually pull that camera into position. So that should be fine. We need to fit the VTX like this into the top of the frame. I've used two thicker straps, wire ties on the main body, and two to support the antenna. It's as easy as that, really. It should be pushed down nice and tight to keep that nice and tight. Again, any vibrations here, I mean, obviously there'll be vibrations in the play, but if that's giving further vibration by being allowed to move, then that really won't help your VTX signals. So now we're just going to join all the components together. So plug in the VTX, and I'm just plugging in the camera here, slightly off camera, you can't see, which is ironic, but there you go. So plug that in and make sure it's nice and tight, pushed nice and home. Again, you know, you could put a bit of hot glue around those to hold those in place. That'd be quite good. The next thing here is just to give it a quick short circuit test, make sure that we've got no short circuits. A little bit difficult to get in film and get the camera here, but all I'm doing is got the tester on the red and black from where the battery will connect, and I've got 7.3 kilo ohms, so that's about right. Okay, so let's go ahead and push that battery home, connect it up, and wow, got a video signal. So if I can get I can wobble the frame around and the video signal moves. I can get these both in shot. There you go. So that looks like it works perfectly fine. So all we have to do now is thread those wires. They're looking a little bit messy there. I mean, you could go over the top of the power distribution board here, I guess, and between the power distribution board and the nays, but personally I prefer them to go underneath, and you should be able to just have enough room to thread that underneath the board pull it out. Not always wanting to go in the direction you want it to go, obviously. I want these things to be easy, but eventually, as you can see, it can go through. It just saves taking those nylon spaces out, and that should be able to push back into there. Make sure it's nice and tough. There you go, nice and seated, push nice and firmly home. And the camera's pointing in about the right direction. We can do the same with the VTX, although the VTX goes up to the top mount. I find that with maintenance they tend to break off where they're soldered to the board, so what I tend to do is, again, push this underneath the power distribution board and let it come up through the front, since the connection on the VTX is on the front side, and it's on the back of the VTX, but to the front side of the model. So push that through again. So it's a case of coaxing it through and finding a space between all the other wires that are now getting, under there. There you go. And that's it, really. So I think that's it then for part 7 of the Bionic Hybrid X210 FPV racing drone building instructions. I think on the next one we'll be looking at fitting the nays, so it starts getting really quite cool now. So we'll be looking at fitting the nays controller, I think, and wiring that in. Then we'll move on to downloading the Clean Flight program, the BL Heli suite, so we can configure the ESCs and things. So it's going to start getting a little bit more technical now from this point forward. But if you like what you've seen so far, please like, subscribe, so you're kept informed when I upload the next one. Thanks for watching.